Hello viewers, welcome to another session of our preparatory e-learning class. What we have for today is a continuation of what we have done in our earlier class. This class is for those preparing for JAM, preparing for WAEC, so please, you can inform your friends to also partake of the class. And we had looked at different laws of indices. So right now, we want to solve some examples to see how we can apply these laws of indices. So let's look at the following examples. This first set of example is just a tip of the iceberg. Just want to introduce you to the elementary examples on how these laws can be applied. As we move on in this class, we will be solving more and more tough examples, and if we can do that, that means JAM will be a walkover for you. Now we have these following examples that we have to solve in today's class, and we'll be looking at a whole lot of other examples. So let's solve the first example, which we have here as the first one, A. In our solution, we have the first one, A, which is 8 power 1 over 3. You should be reminded that this law is our root power law. Now, I had told us anytime you have the power as fraction, that the denominator 3 represents the root. This 3 here is our root, which because of this 3, it is cube root. And whatever you have here is the power. So because of this root power law, we now have this to be solved as cube root of 8. Very simple. Even if you put it to power 1, it does not really mean anything. So you have cube root of 8. How do we solve that? What is the value? How do we simplify cube root of 8? You can do that without using calculator. And of course, you break down 8, you divide 8. What can go to 8? 2 goes to you have 4. 2 goes you have 2. 2 goes you have 1. Because of the cube root, you group these divisors or the factors. Check if they are up to 3. If they're up to 3, of course they are. You pick one of them and write, which is 2. Therefore, cube root of 8 is 2. So the answer to that simple example is 2. We now go on to another example B, which we have B, you have 81 power 3 over 4. 81 power 3 over 4. Still applying, this one is fractional index law. In this law, of course, when you have a fraction as the index, always remember that the numerator of this fraction represents the power, whereas the denominator here 4 represents the root. And in this case, we have 4th root. So how do we do that? We have, this is going to be 4th root of 81 all into power 3. The numerator is the power, denominator is the root. How do we get 4th root of 81? What is 4th root of 81? The answer is 3. Power 3 that we have here. Of course, you know how to find the 4th root of 81. I had showed us in our earlier class, which is what you have. 3 can go here, you have 27. 3 can go here, you have 9. 3 can go, you have 3, and 3 goes 1. Because of 4th root, 4 is here, ensure that the factors you have here are up to 4. Counting, you have 1, 2, 3, 4. You pick one, which is 3. Therefore, 4th root of 81 is 3, and this power comes on top of it. So continuing in our solution, we now have that 3 power 3 is what? That is writing 3 times, expressing this base into 3 places. So 3 times 3 is 9. 9 times 3 is 27. Therefore, 81 power 3 over 4 is equal to 27. We take another example, example C. I hope you understand that. If you have any question to ask, please you can drop it on the comment section of the YouTube channel. Now the example C we have to solve this, which is the same method, the same approach, the same everything, still the same root power law. What do? We have cube root of 27 all into power 2. What do we have there? Now, cube root of 27 is what? We have 3. We have 3. If you break this down using the same method that I did for the other one, you will have the same thing. So we have 3, and then the power here 2 comes on top of it. What is 3 power 2? You have 3 times 3, which is 9. So that is the solution for the C part. Now to get to the next part, which is D. We look at solution D. Solution D, which we have, solution D is 16 all over 81 all into power 3 over 4. This is still the same thing like we have done here, but in this case, the number here is not a single number, it is a fraction. You apply the same method, the same law. So how do we do that? What do we do here? We say fourth root of 16 over 81 all into what? Power 3. Don't forget, when you have a fraction as the power, the numerator is always the power of what you have, whereas the denominator is the root of what you have. So how do we simplify this? Fourth root of 16, you will have it, and fourth root of 81, you also have. So what is the fourth root of 16? You have 2. I hope you know how to get that by way of just explaining it. You divide 16. 2 can go to 16, you have 8. 2 goes to 8, you have 4. 2 goes to 4, you have 2. And 2 goes to 2, you have 1. Because of fourth root, you count. We have up to 4 divisors here. Pick one and write. Therefore, the fourth root of 16 is 2. All over. Do the same thing for 81. Fourth root of 81. What do we have already calculated it here? We have 3 into power 3. Therefore, to continue there, this power 3 is for 2 and 3 inside this bracket. So we have 2 power 3 all over 3 power 3. What is 2 power 3? Please note that 2 power 3 is not 2 times 3. It is wrong, solving it like that. But 2 power 3 is expressing 2, multiplying 2 into 3 places. You have 2 times 2 times 2 into 3 places, all over 3 power 3 is multiplying 3 into 3 places. You have 3 times 3 times 3. What do we have there? 2 times 2 times 2 is what? We have 8 all over 3 times 3 times 3, we have 27. So that is a simple solution to that example. Then we go to this one that looks complicated but is very, very simple. I'm going to bring up some WAEC past questions on this topic and some JAM past questions which we're going to solve. So please continue as we progress with us. All right, the next example is example E, which you have square root of 245 p power 3 q power minus 2 all over 5p power 5 q power minus 6. How do we solve this? The simplest way of solving this, of course, you know that this square root covering everything is like saying is our root power law. You can still re-express this square root as power 1 over 2. How do we do that? You put into bracket, you have 245 p power 3 q power minus 2 all over 5 p power 5 q power minus 6 into power 1 over 2. You can recall that when we have half as the power, it automatically means square root. Therefore, what do we do next? We separate variables. Separate variables. Separate variables. We separate variables. We have different variables there. We have set of numbers p and p as a variable. We also have this. So this is a variable, this is a variable. We separate numbers out from the unknown letters. So how do we go about separating it? We have it here. So separating this variable, we have bracket 2, 4, 5 all over 5 times p power 3 all over p power 5 times, separate these other variables, we have q power minus 2 all over q power minus 6. Now re-expressing this, we have 2, 4, 5 divided by 5. What do we have? 5 cancels itself, 1. 5 goes to 24. How many times can it go? It can go 4 times, remainder 4. Of course, you know, 5 times 4 is 20. Remainder 4 to complete 24. Remainder 4, you move it on the next number 5, it becomes 45. So 5 still divides 45, we have 9. So on this one, we have just 49 times. Applying our division law, we have p power 3. Because of division, we put minus and power 5. Times, we have q, the same thing here, power minus 2. Because of division, please, let's look at this closely. Because of division, we have the first minus, and then minus 6. We have 2 minus there. We have 2 minuses there. Now note, anytime we have 2 signs coming together or coexisting, for example, we have minus and minus, we usually bring in an invisible multiplication sign to separate the 2 signs. Of course, you know that minus times minus is plus. I hope you understand that. Now, moving on, there we have 49 times p. 3 minus 5 is what? Minus 2. Don't forget, let me just quickly show you this. We have, if we have, for example, plus 3 minus 5, minus 3 plus 5, plus 3 plus 5, minus 3 minus 5. Please, these are called directed numbers. These are directed numbers. And how do we understand this? I would like you to know, when we have 2 different signs, like plus and minus, or minus and plus, coexisting in between numbers, when we have different signs, we find the difference of the 2 numbers we have there. First step. When we have different signs, we find the difference. What's the meaning of difference? Difference is answer after subtraction. When we have different signs, we find the difference between these 2 numbers. So the difference between 3 and 5 is what? 2. That is, subtracting 3 and 5, we have 2. Now, what sign should we bring in here for 2? We look at the signs that are attached to the numbers. Plus sign is attached to 3, and minus is attached to 5. Now, which of these signs is attached to the biggest number? We have minus sign is attached to 5. Therefore, because minus is attached to the biggest number, it will appear on the answer. Hope you understand that. When we have different signs, we find the difference as long as the signs are different. We find the difference of the 2 numbers there. Finding the difference or subtraction of the 2 numbers, we have 2. Next thing, look at the signs. Which sign is attached to the biggest number? That sign automatically comes with the answer. That's for the first one. Now for the second one, same thing, different signs, minus and plus. So we find the difference of the 2 numbers, 5, 3, and 5. It can be any other number. So I'm just using 3 and 5. So the difference of 3 and 5 is what? We have 2. You hold on. You look again. Which sign is attached to the biggest number? We have plus attached to 5, bigger than 3. Therefore, we have here positive 2. Hope you understand that. Whereas in this one, we have same signs. We have same signs, plus and plus, minus and minus. When we have same signs, what do? You add, you find the sum. You find the sum. For same signs, you sum. For different signs, you find the difference. Hope you understand that. For same signs, you sum the numbers, and the same sign that is used will go together with the answer. For example, here we have plus 3 and plus 5. Sum the numbers, we have 8. What is the same sign there? Plus. So the answer is what? Plus 8. Now, in this case that we have, I know you can easily get this on your own. With this one also we have same signs. When you have same signs, minus and minus, you sum the two numbers, which will have what? 8. Now, what same sign is used there? Minus. So the answer is what? Minus 8. This is just to refresh your memory on what you've done in your junior secondary. I hope you understand that. Applying that understanding, here we have positive 3 minus 5. You know, this 3 here, because even if there is no sign, this 3 has an invisible positive sign. So positive 3 minus 5 is negative 2. Bringing in this understanding. Now, same thing here for Q. We have Q. Negative 2 and positive 6. That's minus 2 plus 6. So difference of 2 and 6, you have 4. Now, which sign is attached to the biggest number? Positive. So it's supposed to be positive 4. You can leave it there as 4. I hope you understand that. We proceed. We should bring in power 1 over 2. Now, let us bring back this power 1 over 2 on each of these. This power here distributes evenly on what you have here. So this is going to be, we have 49 into power 1 over 2 times p power minus 2 into power 1 over 2 times q power 4 into power 1 over 2. So to proceed further, we now have this 49 power half. It's like saying square root of 49. And what is square root of 49 is what? 7 times. Now look at this. These are letters with powers. Now look, this minus 2 times 1 over 2. Just like having minus 2, bracket here means times, power 1 over 2. This is like saying 2 over 1. Hope you understand that. So this is going to be 2 cancel 2 down here. 1 times minus times 1 is minus 1. 1 times 1 is 1. So minus 1 over 1 is minus 1. So in place of this, we have minus 1 there times p into power minus 1 times q. Look at this. Same thing. We have 4 as a power multiplying power 1 over 2. This is like saying 4 over 1. You know, numerator cancels denominator. You have here 2. 2 times 1 is 2 over 1 times 1. You have 1, which is what? 2. So you have positive 2. On top of that, q. So we have that. To proceed, we now have to express that. Don't forget that when you have power minus 1, it means 1 over. So we have here 7 times 1 over p. This 1 over has taken care of this power minus times q square. Our final answer now would be 7 times 1 times q square is 7q square all over what? P. I hope you understand that that is the final answer. So these are the solutions for the first set of examples that we have solved. Now you're going to look at another set of examples which are quite tougher than this. Don't forget I told you that this is a tip of the iceberg. But if you understand this, then that means you can apply the same understanding in our next examples.